We're going to finish up section 1.2 today in the videos talking about the domain and range of a function. So I have the definitions of those two terms here. The domain is the set of all possible input values for a function, and the range is the set of all possible output values for a function. So if you remember, we were thinking about a function like a machine. So here was our function, and we were plugging in values. This was our input, and then the function would give us one and only one output for each input value. And our input value was usually represented by X, and our output was usually represented by Y. So when we're looking for the domain of a function, we're looking for all the possible values of X that we could plug into this machine, and the range is going to be the pile of all possible output values this function could ever possibly give us. If it's helpful to you to remember it, domain and range, X and Y, input and output, they all go in the same alphabetical order. So let's start off thinking about domain, and we'll start off by thinking about this function here, f of x. And when you're looking for the domain of a function, generally we think about it as being all real numbers, the whole real number line, any value of x that we want, except for the ones that cause us problems. All right, so if I think about the number line, are there any numbers that I might try to plug into this function that would cause a problem? And the first problem number is x equals 5. If I plug in 5 for x, I'm going to cause 0 in the denominator, and we know we can't divide by 0. So I'm going to go over to the number line and say, whatever this domain of this function is, I know it doesn't include 5. So I'm going to put an open circle at 5. Remember, that's our notation for I don't want to include this number in my answer. All right, so our first rule about domain of a function is going to be that we should never divide by 0. We want to exclude numbers that cause division by 0. The second rule is going to have to do with that square root. We are going to avoid taking the square root of a negative number. So you may have learned in high school about imaginary numbers. You might have learned that the square root of -1 is equal to the quantity I. And imaginary numbers are horribly misnamed. They're not imaginary. They actually do exist. It's just that people thought they didn't when they first started thinking about them, but they have lots of applications in engineering and physics and all over the place. So we know that they really do exist. They're not imaginary after all, but we don't study them in calculus. So since we don't study them in calculus, we're also going to ignore them here in pre-calculus. So we're going to avoid taking the square root of negative numbers. So I'm going to go over to x equals 0 here and say I'm only going to plug in numbers to this function that are to the right of 0, where they're positive. So I'm going to shade only to the right. Obviously, I'm not going to shade 5 because I can't plug that into this function. So I'm going to skip over that and say, but anything bigger than 5 that's still positive, I can plug into this function. And you actually can take the square root of 0. So it's okay to go ahead and fill in the circle at x equals 0. We just don't want to go past x equals 0 over to the left. All right, so this is going to be our domain, any positive number bigger than or equal to 0 except 5. Now, in this class, when we list the domain or range of a function, we're going to do so in interval notation. So interval notation is just a symbolic way to represent what I've just drawn on the number line. I'm going to write this domain down for us in interval notation, and then I'll explain where I got all the symbols from. So in interval notation, this would look like this. So the first interval that you see here, this 0 to 5, that's representing that first chunk of the number line that I have shaded. Okay, so I put the left and the right hand limits, the 0 and the 5 on it. And then I put a bracket, a square bracket on 0 and a parentheses on 5. A square bracket is equivalent to that filled in dot. The parentheses on 5 is equivalent to that open circle. So that represents all of the numbers between 0 and 5, including 0, not including 5. The next interval that I've got there, 5 to infinity, represents the right-hand part of that domain. All right, so I put the endpoints on there, 5, the arrow is infinity, and then I put parentheses on both of them. Again, the parentheses on 5 is because of that open circle. I don't want to include that. The parentheses on infinity acknowledges the fact that infinity is not a number. It's a concept. It's an idea. You can't be equal to infinity. So we always, always, always put a parenthesis on infinity. And then you've got this U here in the middle. That U stands for union. That means that both of those intervals are part of my answer. So we kind of marry them together with a union symbol. All right, for now, these are our two domain rules. We want to avoid dividing by 0, and we want to avoid taking the square root of a negative number. An even root of a negative number, we also couldn't take like the fourth root of a negative number. All right, so those are our two domain rules. As we get more sophisticated through the semester and we learn about more kinds of functions, we're going to expand this list to include more rules. But for now, these are our only two domain rules. All right, so let's put these two new rules to good use. We're going to find the domain of this function. So I can't have any numbers that cause division by 0, and I can't have any numbers that cause me to take the square root of a negative number. This function doesn't have any square roots in it, so I really don't even need to worry about that rule at all. All I have to do is make sure that this thing down here in the denominator never equals 0. All right, so we're going to solve that 2x minus 5 not equal to 0 the same way we would solve an equals to equation. So I'm going to say 2x minus 5 not equal to 0. Let's solve that for x. So I'm going to add 5 to both sides. So I get 2x should not be equal to 5. Then I'm going to divide by 2. And I get that x should not equal 5 halves, or 2.5. All right, so I'm going to go over and draw this on my number line. Drawing this on the number line is optional. You don't have to do it, but I think it makes it easier to write it down in interval notation in the end. All right, so all I need to do is exclude that number at 5 halves, and that's the only number that gives this function problems. So I'm going to say anything else to the right of 5 halves and anything else to the left of 5 halves is okay. All right, interval notation, you're always going to build left to right. So on the left-hand side, I've got that arrow. That's our negative infinity arrow. So we're going to say from negative infinity, put a parentheses on it because we always give the infinities parentheses, all the way up to 5 halves. But a parentheses, meaning I'm not including 5 halves. I've got another half of the number line to represent, so I'm going to need that union symbol again. And we'll go from 5 halves to infinity. And that's the domain of our function. Next up, square root of 4 minus 3x. So like the last one, I only need to worry about one rule in this function. I don't have a denominator, so I don't need to worry that I'm going to plug something into the denominator and cause division by 0. All I have to do is make sure that I don't take the square root of a negative number. Now, that doesn't mean that I can't plug in negative numbers necessarily. It just means that whatever this thing is, the 4 minus 3x, that has to stay positive. So we're going to say that has to be bigger than or equal to 0. That's just solving a little linear inequality that you learned how to do in high school. So we're going to say 4 minus 3x is greater than or equal to 0. And then we're just going to solve for x. So I'm going to subtract 4 from both sides. And I get negative 3x greater than or equal to negative 4. Divide both sides by negative 3. And I get x. And then on the right-hand side, I'm going to get a positive 4/3. And I picked this example to remind you of this. You may have forgotten, when you're solving an inequality and you divide both sides by a negative, you have to remember to flip the inequality. So that greater than or equal sign is going to become a less than or equal to sign. So our domain is going to be x less than or equal to 4/3, 1 1/3. So I'm going to go over to my number line. And here's 4/3. And I'm going to shade x less than, so to the left of 4/3. And or equal to. So I'm going to fill in a closed in circle there. All right. So we can see this function actually doesn't mind negative numbers. That negative 3 coefficient on the x makes the negative x values turn positive, and the square root's happy with the result. All right, so let's write this in interval notation, always going left to right on the number line. My left-hand endpoint is negative infinity again. And I'm going to go all the way up to 4/3. This time I want to include 4/3, so I'm going to put a square bracket on there. And we don't have a second part of the number line to represent, so this whole thing is our domain. Next function, h of x here, 2x squared plus 5x minus 1. This one is kind of so easy that it's hard. In each of the last two examples, I've been ignoring one of the two rules because they weren't relevant. Here, neither one of the two rules is relevant. I don't have a denominator, so I don't have to worry about dividing by 0. And I don't have a square root, so I don't have to worry about taking the square root of a negative number. So there's no numbers on this number line that are offensive to this function. You can plug in any number that you want to into this function. So we're going to represent the whole number line as our domain from negative infinity all the way to positive infinity. Last example in this video, x over x squared minus 9, we're going to find the domain. Again, I don't have a square root, so I don't have to worry about taking the square root of a negative number. I do have that denominator though, so I need to make sure that this never equals to 0. All right, so I want to set x squared minus 9 not equal to 0. And that's a quadratic equation. We can solve this a couple of ways. You can factor x squared minus 9. That would be x plus 3 times x minus 3. This one doesn't have an x term in the middle, so we can actually solve this one really easily by taking square roots. I'm going to add 9 to both sides. and I get x squared not equal to 9, and then take the square root of both sides. The only thing about square roots is whenever you use them to solve an equation, you have to remember to put a plus or minus on the number. So we're going to say x is not equal to plus or minus 3. So this function has two numbers it doesn't want you to plug in. So I'm going to go over to my number line. Again, graphing this on the number line is optional. If you can get to interval notation without it, feel free to skip the graph. All right, so I'm going to cut out both of those numbers. I'm going to cut out -3 and cut out +3. Everything else on the entire number line is allowable for this function. So everything from -infinity up to, but not including -3, everything in between the two, and then everything to the right of +3. So this one is a pain to write in interval notation because you have 3 separate parts of the number line that you want to represent. So you're going to need 3 separate intervals with u's in between them. So left to right, I'm going to read off my number line, -infinity to -3, but don't include it. From -3 to +3, but don't include them. And then from 3 to +infinity. And that's the domain of our function. All right, so here's how we're going to calculate domain by these rules in the pink box. In the next video, we're going to talk about calculating domain and range by looking at the graph.